everyone. My name is Kelly Hall. I'm a marketing coordinator for ALS North America. I want to thank you all for joining us today for our Webinar Wednesday series. Our presenter today is Ron McLeod. Ron received his Bachelor of Science degree in chemistry from McMaster University in 1975 and a PhD in organic chemistry from McMaster University in 1983. He has been a manager and a technical specialist in the environmental lab testing businesses since 1985, including being the general manager of PCS Analytical and COO of Axis Analytical. In 2005, he joined ALS to specialize in HRMS and air toxins analysis. Now, Ron serves as the Director of Air Toxins and Special Chemistries in Life Sciences at the ALS Burlington Laboratory. Today, Ron will be discussing and analyzing flame retardants. During this presentation, feel free to use your chat box, ask a question, or raise the hand features to ask questions at the end of this presentation. Ron, thank you for taking your time to deliver this today. I will go ahead and turn it over to you.
So, do you want to go over the target groups, structures, identification of environmental concerns, and identify potential monitoring priorities? Part of this is an overview of what flame retardants are all about, what they are and their impact to the environment, but part of it also is a personal perspective on where I perceive things are going or not going particularly well. Organic flame retardants come into two general classes. They're divided into multi-component or polycongener types and single components. The multi-component type include diphenyl ethers, brominated biphenyls, chlorinated naphthalenes, chloroalkanes, or otherwise known as chloroparabens. And single component include melamine and its derivatives, phosphates, and other halogenated targets. Melamine I'll be ignoring today, but covering most of the others. Now, as far as flame retardants, there's a bit of a moral dilemma, and what it is a compromise between two competing issues. One is prevention of fire and protecting people's health in that manner, and the other is versus protection of the environment. I think that to me, one of the more insidious aspects of this is that there's an issue of release to the environment. And that happens before there's really an overall impact to the environment. Now, most of these chemicals, fortunately, are not particularly toxic to humans, not zero toxicity. There's certainly endocrine disruptor issues associated with some of them. But in the really terrible impact on some of those is the impact to the environment. General properties, most of these compounds are stable and persistent, not surprising because they are being added to commercial products. In order to be viable for that, they need to be stable for long periods of time. And in general, because they're plastics and so forth soluble, they tend to be lipid soluble and bioaccumulated, all the bad stuff. And the other issue, which is really important, is that it is global. There's global distribution. And unlike some other contaminants, even like pesticides, these are at percent levels in commodity products. So huge amounts of these materials are being produced. Huge amounts of them are being sold in the form of commodity products and percent levels. 8 out of 24 of the Stockholm Convention Annex A targets for elimination are in the flame retardant class of compounds. Most of the other ones are in the pesticides class. And again, these things share, certainly on the organochlorine pesticides class, issues associated with chlorinated or halogenated materials and long persistence and large amounts released to the environment. This doesn't necessarily mean great protection. I want to remind that it takes a long time for compounds to get onto the Stockholm Convention list. Good news is, in general, the mammalian toxicity is low, but there are certainly other species, especially aquatic, which have concerns. Complications on this, release to the environment, of course, at levels which are pretty high. Knowledge of toxicity on selected species types is limited, but I'll tell you that I attended the BFR conference, the brominated flame retardants conference, which is a bit of a misnomer because it does all flame retardants. And I was astounded to know how much data there was out there on the toxicity, for example, the phosphate plasticizers and flame retardants. Accessibility to low-level analytical techniques is an issue. Some of these things are difficult to analyze and limited labs offer these type analysis. Also, flame retardants, many of them fall into both flame retardants and plasticizer classes. Is that really important? No, a general class, we'll call them all flame retardants for today. And products are sold as mixtures to be added to certain plastics. Industry trends, I'll get back a little bit more into the structures in a bit, but turning away from the aromatic polyconjugate materials and offering cocktails of single component products, flame retardants mixed with plasticizers all together, on offering a diversity of single component. The one issue is the bottom, which I consider a little bit insidious, is that the industry just keeps on keeping ahead, or appears to be, on the environmental impact assessments. So is there any that starts to get into the area of notoriety now, this issue about rapid changing and customization of products? They just bring out a new product. In fact, there's a couple of, I know one, and I think two examples of in this field, where two compounds, or certainly one compound, was found in the environment before it was even known that it was being used as a plasticizer. Routes of entry into the environment. There's actually a fourth primary way. There's certainly municipal sewage, and that coming from laundry. I think that's probably the largest of all. Huge amounts are going out of the municipal sewer systems. And it has to do with primarily laundering of clothing and furniture and rugs that are being washed and dumped down the sinks. Also human clearance probably, but I'm sure that the relative amounts is the laundry most over the human clearance. Product release, certainly landfills, dumping and recycling. This more relates to the electronics type plastics, that sort of industry, and through contact and leaching, chemical manufacturing release. These other two are primarily regional, whereas the first one on the municipal sewage is more or less global, and again, huge amounts. There's a fourth area that I realized missed on this slide, is also the use of flame retardant foams and so forth in combating fires. Again, this can be very high levels of certain flame retardants, but it's, again, pretty regional, very specific to where it's being sprayed. Now onto the subject of the structures. The multi-component targets that have been used a lot historically, especially the brominated diphenyl ethers, brominated biphenyls as well, and chlorinated naphthalenes a bit. These are all polyhalogenated aromatics, two rings, depending on how much chlorination or bromination, depends on what products. So there are a number of products. You'll note that all three of these classes are on the Stockholm Convention Annex A targets. In fact, the brominated diphenyl ether hits it 3 times because of the different products from different levels of bromination in that case. Differences here on the sort of patterns that you see on chlorination or bromination. The chlorinated naphthalenes, a pretty broad suite of 75 possible structures. The other two, 209. Unlike PCBs, which have 209 conjugate possibilities, the upper two really are quite selective in the domination of certain structures. And certainly on the brominated diphenyl ether, it has to do with the oxygen and orthopara direction, and that's of interest to you. But yeah, the top two become relatively easy as far as monitoring if you want to do a select few of high concentration targets. Chloroalkanes or chloroparabens fit into a different category. The short chain category, which again depends on the chain list of the hydrocarbons that we're talking about, that is also on the Stockholm Convention list, and so identified as being quite toxic. The mid chains and long chains less so, but it doesn't mean that those are great. But it means that after the short chain was identified as being particularly toxic, there's been more and more movement to reduce the amount of short chain and push it towards the mid chain. Again, these guys are released and have been used in huge amounts in plastics. And so they are also out there in the environment. And unfortunately, the analytical tools have been difficult. There's two reasons for it. One is that in this case, there are no structures that dominate, and you've got thousands of possible structures. So when you chlorinate the alkanes, you get a huge mix, and you don't, if you're doing chromatographic determinations, you don't see a single peak, or you don't see a select few peaks. You just see a mash. And on the bottom left-hand corner, there's an example of the sort of thing that you can see for monitoring chlorinated biphenyls. You don't see any individual. This is just showing a sort of a mash of congeners over a long retention time window in which there really isn't any resolution of any individual congener. So what that means is that you've got a number of possible structures. So when you're looking for a total concentration, there's no one thing to monitor that comes out strongly, because it's distributed over a large number of possible congeners. So its responses become an issue. That's one reason why it's been a problem. The other reason has been, there are some analytical techniques, but there's still arguments within the analytical industry on how well you can analyze or how well you can quantify them. So that there's a lot of overlap on these things between the short and mid chain. Getting an accurate number of what it is up and still controversial. But my opinion on this is under monitored and should be looked at a lot more. But even if you're getting relatively poor quantification, at least some data is better than none. Phosphates, again, huge quantities being manufactured, and these are being used for both plasticizers and flame retardants. I have a general structure on the upper left-hand side, phosphate with 3 R groups. Usually the 3 R groups are the same. There's aryl and alkyl type side chains. The tricrysyl, the triphenyl have been used in huge amounts. They actually tend to be the more toxic, the aromatic ones, the alkyls less. Again, you start getting at the bottom of the right-hand list and you're getting back into the flame retardants with both phosphates and chlorines present. The ones at the top of that list tend to be more towards just plasticizers. But again, this category hits, these in general hit both these categories of flame retardants and plasticizers. Other halogenated flame retardants, I've got a couple of slides of examples of them. Not expecting you to recognize or know them all. That's not the point. The point is that there's a plethora of these things, and again, these are sort of customized, not just for the plastics they're being assigned to and associated with, but also, well, this is a guy who's getting notoriety in the environment, so let's change it. So there's a lot of customization. You'll see in this slide, you've got an example of a number of chlorines, the D-chlorine plus. You've also got one that has both chlorines and bromines. A lot of others, and the 3 more on this slide, and on the next slide, all with bromines on them, different type structures. I'll go back. You'll note the hexabromocyclododecane is also in the Stockholm Convention Annex A target list. Again, I remind you that it takes a long time for things to get to the notoriety of making it to the Stockholm Convention, maybe 10, even 20 years before things get there. Now we get into a little bit more of my perspective on it. What ones are most concerning and under analyzed and under examined? The brominated diphenyl ethers have been out there for a fairly long time. Their use is reduced. It's not being used as much in new materials that are being sold out there. Right now, that doesn't really matter. There's still huge amounts being released because of the amount of products that are out there. Probably brominated biphenyls, the polychlorinated naphthalenes, They tend to be quite regional as far as exposure, because there's not a lot of products now, and haven't been a lot of products that sold for a while with those materials in them. They weren't used to the extent of the brominated diphenyl ethers. Hexabromo cyclododecane and D-chlorine plus certainly of concern. They have been monitored a fair amount. The ones that to me have been under monitored are the ones that are in green, the chlorinated paraffins, particularly, and phosphates. And I want to note that these tend to be at much higher concentrations and yet have been fairly not being emphasized as far as monitoring and out there. The other halogenateds, it's again, that's a mixed bag. Some of them are new, some of them are legacy, but there's a lot of them, and so I think that it's important because of the plethora of them to be monitoring for those as well. So this slide gives both the expected concentrations and common instrument methods. It's not intended to be the only approaches, but in fact, in order to get the levels that we're looking for, it's generally fairly expensive methods. You'll see EI stands for electron impact, and that has to do with the mass spec ionization approach. High-res MS you'll see in there. You'll also see the hexabromocyclododecane is typically done by LCMS-MS. It can be done by GCMS-MS, but the hexabromocyclododecane has specific congeners, and if you want congener analysis, you don't get that separation by GC, you need the LC. On the chloroparaffins, ECNI for electron caption, negative ionization. It's a special technique. In general, it's done by low res, difficult to do by high res, but not impossible. But it needs that specific high sensitivity method, at least ECNI, low res MS, in order to get to reasonable levels to be able to monitor. And there are a couple of labs that are offering that, including ourselves. Let me go on to the next slide. So challenge how do we look for the right targets? You've got the issue of detectabilities versus methods versus cost. And again, it's a variety of targets, a variety of analytical techniques. You can't really hit all flame retardants in one analysis. It requires cost, it requires specific targeting, and it's also important to ensure that target listing is relevant. Now, how do you do that, and how do you look for the right thing? And I would like to see over time a little bit more coordination between government agencies championing the initial research and the labs, because when it comes to publication of RFPs on what programs are being done, there's not much in the line of discussions on what are the new emerging ones, what would you like to see, and so there's not a good coordination between the labs and what target lists and what we really need to be monitoring. So I'd like to see more publicly and privately funded research coordination with the private labs so that we can do a better job of offering targets. But that doesn't mean we don't have a fairly large listing on all of these type compounds. It's where I'm really coming from is the phosphates and the other halogenated flame retardants. What's coming? What are the great ones of concern? We'd rather be advised rather than be reactive on this. This slide here is my bad attempt at a risk matrix so that you understand the couple of slides before where I was identifying some of the priorities. And included on this is the Stockholm Convention targets. Are they on that list? Yes or no? For example, the chloroparafins, the short chain are, the medium and long chain are not. Are they legacy products? Yes or no? Are they current being used? Yes or no? R stands for reduced, so that gives you a general idea of what's being put out there right now into the environment. Expected levels, of course, are important, where a lot of them are in the PPQ levels. But on the chlorinated paraffins and the phosphates, you're looking at ppb levels in the environment. So that was the basis where I came up with the my personal perspective, where I think things need to be going as far as future is concerned and more monitoring. Summary: all target groups are environmental concern. Chlorparaffins, phosphates, and actually also halogenated flame retardants, in my judgment, need more attention and monitoring. That's my presentation. I hope that's been useful. Any questions? And now I have to find a way to make sure that I get to hear what everybody's asking here.
I do not see any questions coming in. Feel free to email me or Ron at ron.mcleod@alsglobal.com. I want to again thank everyone for attending today and enjoy the rest of your week. Thank you, Ron.
Thank you.